Perfect, perfect. Great, great. And first of all, welcome to this great session. And I'm really thankful to all of you. Let me also check if it's going live or not. Yeah, it seems to be going live right now. All right. Okay. And I'm just little uncomfortable right now with respect to the interface here and there. Okay. All right. All right. So great to have all of you in this session. Thank you for making this session really useful. Really, I would say really happening because of joining it. Great. Wonderful. All right. As part of this session, what I'm going to do is I'm going to walk you through what does it mean by a system design interview and how would you attempt to solve the system design interview. Usually, the system design interviews are considered the hardest, and almost every company out there, every software engineering company, they ask system design questions. So without further ado, I'll start with the session. I'll start sharing my screen, and it's being also also live on the YouTube. Okay. So is my voice coming through fine? Everybody can see me and hear me? Yeah. You can respond on the chat, as well as you can respond on the YouTube one. All right. I'm going to be looking out at all the three chats. And yeah. So great to have all the people here. And a question from Saket is that, is it relevant to machine learning engineering jobs? Yes. So usually when people are interviewing a senior engineer, they ask multiple kind of questions. They have different rounds of interviews. And the first kind of interviews that you will see is like normal software engineering questions, like coding questions. And then the second kind of rounds you will see is the software design one. And if you have opted for machine learning, they will ask you the machine learning system design questions. Okay. The straight questions on machine learning, people have stopped asking, like people asking about, explain to me what is decision tree. Nobody asks those kind of straight questions anymore. People more focus a lot more on machine learning system design as well as system design. All right. And all right. A quick question from somebody is that, is it useful for somebody from the QA background, the quality assurance background or testing background? My answer is yes. Okay. If you look at closely, most of the QA engineers are also really good engineers, and you will be asked the system related questions in your interviews. Okay. Because people who have to test the software need to know how software functions, and they need to know various kinds of interfaces, because it's not only the UI that gets tested. There are integration tests. There are various kinds of unit test cases. Then there are, the smoke test and everything. You have like 100 kind of testing, and you can only do that effectively if you know how the softwares are designed. These days, a lot of testing goes in individual microservices or services. All right. And okay, that's a good question. I'll try my best to keep this interactive session. And let me just once more confirm my audio settings if they are as per what. Okay. All right. Okay. All right. So this is the format of the session. The session is going to be, I'll briefly talk about CloudxLab, then I'll briefly give you an overview about my profile. And I'll also explain to you what it means by software engineering role. And then I'll talk about process and like what is the usual process of hiring software engineers. And then I'll talk about design round. I'll talk about the design round in more details. I'll talk about, we'll take up a question, we will propose a solution, then we will fine tune the design and so on. So those are the things that I'm going to discuss as part of the design round. Okay. The session is going to be 2 hours with 10 minutes break. And except for the speaker, everybody's on mute. And so you can use the YouTube chat to ask questions. The recording and the slides will be shared after the session. All right. All right. A question is, what's the difference between system design as well as machine learning system design? So machine learning system design interviews are around checking whether you have an understanding of how would you go about building a machine learning model or building a system which does the machine learning. Like, for example, there's a very thin line difference, by the way. Like, for example, designing the Facebook feed is a system design question, but ranking the Facebook feed is a machine learning design question. Similarly, how would you build Amazon like recommendations from the algorithm perspective, from the model perspective, is a machine learning system design interview question, while asking about how would you build the Amazon landing page is more of a system design problem. Okay, I hope you get the idea. So machine learning system design includes both the things, your understanding of the system design, as well as your understanding of machine learning. All right. So I hope that gives you a perspective. So we will move forward. A brief idea about CloudxLab. The core vision behind CloudxLab is that engineers and IT professionals across country needs a hands-on education. Those days are gone when people used to mug up the theory and they would basically just get through the interview rounds. These days, the skill that is needed is how much hands-on are you? Will you be able to build things by yourself, right? Even as of today, whether you're going for product management role, QA role, quality assurance role, or you're going for DBA role, or you're going for, a particular, like say, front-end engineer role, or say, for example, back-end or full-stack engineer role. Now, people check for your hands-on knowledge. And a number of people have stopped looking at degrees and various kinds of past experiences. They focus a lot about your understanding and how much hands-on you are, right? And that's why the vision was to give people an experience whereby people can do hands-on and learn better, okay? Theoretical days are gone. Those days were good when there were very few engineers and, right, we needed more supervisors or program managers than the actual engineers. So those days are gone. And right now there are quite a few of the people who can talk, but there are very few people who can actually do hands-on, who are very hands-on learners. And that's the irony about most of the courses like Udemy and almost all the people who are running these courses online. their system is not bottom-up design with hands-on in mind. They are just, it's just, a place where you get the video lectures and this and that. I mean, that is there on YouTube as well. What's the point? You really would not enjoy most of these theoretical courses, as well as the learning you will get from there will be mostly useless. Okay. You might memorize entire thing, but you won't be able to use that knowledge. Okay. So the right way of learning is by doing the hands-on. And that's my appeal to everybody. No matter what is your target, whether you want to go for certificate, you want to go for master's, you want to go for PhD, focus a lot on hands-on. Focus a lot on hands-on, because that's what makes people. That's what, when, let's say, you finish your master's or you finish your graduation, the company is going to, hire you only if you have hands-on knowledge. I mean, most of the company, most of the smart engineers and senior engineers know how to figure out whether you have done hands-on or not. And that's the key idea behind CloudxLab Playground. In CloudxLab Playground that you see, on the left-hand side, you see a theory question, the theory of the question. On the right-hand side is the Jupyter notebook embedded into the playground. So you can go to CloudxLab and try out the platform. Okay. So my request will be that finish all the exercises at CloudxLab by yourself. Do not just, I heard lots of people just hiring other people to get through with these exercises somehow, right? That's not helping. That's not helping. If you want to become fit, do the exercises in gym by yourself, right? Just because you purchased a very expensive gym membership by very expensive, very big brand will not help you become fit. The only way to become fit is doing exercises. Similarly, in the coding, no matter where you take the course from, do a lot of hands-on. Do a lot of hands-on. And we have stitched that experience into CloudxLab. Whether you are learning Python, whether you're learning Go, whether you're learning Scala, or whether you're learning Linux. So we have all these tutorials except for the Go right now, but we have the lab there. Okay. Like, for example, if you finish the Linux tutorial by yourself, I can guarantee that you'll be able to clear most of the Linux interviews. Similarly, Python. Now, nobody will ask you Python language-specific questions. They will ask you a question like, how would you solve this? How would you build this? How would you, they'll give you a coding problem and you have to code it, right? Similarly, nobody will ask you a theory question that what is Linux? No, nobody is going to ask you that. The question they will ask is, how would you, what commands will you use to accomplish this? What kind of pipeline would you use? Similar is the case with SQL. So we have a very hands-on tutorial on SQL. We have a very hands-on tutorial with Hadoop, Spark, and almost all the tools that you have heard of. We'll have tutorial with a similar playground embedded on the right-hand side. When you finish the task, right, whatever is instructions are written here, when you finish these tasks and click on submit answer, that will make you very hands-on. Okay. And yeah, one of the very important thing that we have in our course is that we have lots of the whole learning path that you see is essentially a very, very sequential. Okay, so you start with Linux, Git, then you go with Python, then you go ahead with other things. So that essentially pushes you to learn a lot. Like, I'll just show you. If you take a look at, say, my courses. So if you take a premium subscription, you will get access to all these courses that you see at the top, right? And you'll get access to data science specialization. All of these courses are included in our premium subscription. Not only that, you will get the lab. So essentially, I can guarantee that nobody has an equivalent offering on the planet when it comes to the technology learning. Okay. Some people are just offering courses. Some people are just offering degrees, and people are not integrating the learning experience with your career. Okay. So my request is, thank you, Sudiksha. I'm really happy that you found the CloudxLab's hands-on environment really good. And yeah, so coming to a very important point. So here, let's say you want to learn DevOps, okay? And also I want to suggest something very important to everybody. Most of the tools or most of the things are not really you should plan for. You should not plan for like you want to become a DevOps engineer only, right? No. Being a software engineer, what you have to aim for is you should be good at systems, you should be good at coding, and rest of the things will follow. Okay. Like, for example, this course, like if you just go through this course quickly, you will be able to figure out everything. And I would strongly recommend here also, even if you're going for DevOps, you start from the top, like finish Linux first, then you, right? The finish Linux first, and okay, and then go with Python, then right, and so on. Then you start with the rest. Now, and also Git have to. Now, the important part I want to say is that if you go for data science specialization, same thing. If you finish this one is get ticked. Similarly, it is optional, so you can skip this one. But SQL tutorial, I would want you to finish, and then these are all the tools that you need for data engineering. These are all the tools that you need for data engineering. And yes, here what you'll see is there's another course called Big Data with Hadoop and Spark and so on. So everything is well organized, and these are shorter videos, and everything is very focused towards hands-on. Okay, so I think out of right, I mean, there should not be any question in your mind if you want to just take up a premium subscription, because you get all these courses bundled in single shot. And yeah, you can go ahead with that. And similarly, we have most of these things are basically subsets and supersets of the same things. And you will realize that part as you go ahead. Okay. So essentially, my request to all of you will be that pick any of these and keep moving forward. Okay. Keep moving forward. And I do not discriminate between one job versus another, because software, at the end of the day, these are not like sportsman versus musician. No, right? DevOps course is not like, okay, I'm software engineer, so I should not do DevOps course. No, that's a wrong attitude. The way you should always plan is that when you, let's say, are joining a company, the chances are that the company will have servers, company will be deploying something, company will be creating services, and so on. So this DevOps course will actually be very helpful for any software engineering, software engineer or software engineering role. Okay, most of the engineers are supposed to do it. Now, similarly, if you are going for a software testing, maybe your first job into software testing, but make yourself comfortable with Python so that you can automate using Selenium or other tools. There are so many tools. Also, this will help you become an automated tester. Okay. And I mean, those people, some people ask me that I am planning to be a product manager. Should I go for software engineering? My answer is yes. The great product managers I have met in my career are those people who have a good understanding of software engineering. Okay. So software engineering is inevitable. Even if you are a data scientist, when you try to deploy your models, you will have to do software engineering. There is no escape. There is no escape. All right. And yeah, my suggestion will be that do not worry about whether a particular skill is going to be useful to you or not. Almost every skill that is mentioned on your in the premium plan is going to be helpful in making you a big engineer. Let's say, for example, DevOps. So DevOps course is if you are a software engineer, DevOps is anyway needed. If you are a machine learning engineer, DevOps is anyway needed because you will need for MLOps, you will need all the understanding of DevOps. Okay. You don't have to memorize anything. You just have to do hands-on with all the tools. And by the time you finish doing hands-on, you will realize that you don't need to memorize anything. Okay. So that's my suggestion. Apart from an integrated environment, we have this hands-on environment here. Like you can just get a console. You can get a console and you can also put things like you can do whatever you want there. You have all the access to the data sets and everything. Okay. So my request is that I mean, you should definitely go for lab or premium subscription. Premium subscription is the most value for money. You get lab as well as all the courses, and you should not hesitate in just spending that money. This is because we pay money to Google and everything. That's why we have kept the cost of the content to be very small, because our main expenses are around supporting the lab and paying Google and Google and Amazon for the lab. Okay, so this is a lab where you get all these tools bundled at one place. You are free to do all the experimentations. Okay. And these courses are, yes, can prepare you for PhD. So yeah, I mean, if you look at the machine learning course, our machine learning course are actually the most detailed course that you will find out there. Like, for example, in this course on machine learning specialization, you have, reinforcement learning, you have autoencoders and generative adversarial learning. And essentially, this is something that you would need in your PhD. Okay. Similarly, in case of data engineering, I can guarantee that once you finish like this first part of data engineering, you will be able to complete and come up with your own PhD thesis. All right. So yeah, this is something that I would recommend everybody to go for. The premium subscription is must have. Okay. There's a social angle whereby there's a very active forum. There's around every course, there are people. You can just message people and chat with people. I mean, not chat with people. You can message them. They'll receive an email. They can reply to you. You can follow the people. And there's a news feed, and people can use the news feed and post anything they want. Okay. Now, so we have a lot of hiring partners. So we conduct the placement eligibility test. If you have not enrolled for our placement eligibility test, go to our website, go to resources, you will find the placement eligibility test. Like here, if you go to resources and you go placement to here, you'll find placement eligibility test. Okay. Okay. It's mostly about that. All right. So all right. Now this is okay. Now let's start with the system design interview. Okay. And yeah, one of the things that I want to talk about is the okay. All right. So there is a common question that keep coming into the chats is that will I get a certificate or not? You will get a certificate. So my request is focus on the webinar. My personal request to you. You might be hard pressed for certificate. Yes, you will get a certificate, but um, please focus on this session. This is not a sales pitch. This is not a marketing pitch. This is detailed session on how to plan your career as a software engineer. You might collect all kinds of certificate. If you are attending our webinars in past, you must have collected probably 20 certificates by now. But I mean, certificate can only get your resume picked up. But in order to clear the interviews, you need to understand what it is. Okay? So my request to everybody is focus on the substance right now. Certificate you will get. Okay. And yeah. And this is important because in today's time, almost every job is software engineering. Okay. Whether you're going to become a chemical engineer or mechanical engineer, there again, your primary role is going to be software engineering. Okay. If you are good at software and then become mechanical engineer, you will do wonders. You will do magic. You will do lots of simulations, lots of research. Okay. So my suggestion is no matter what you plan to become, have a good understanding of software engineering. Okay. Even if you want to be go into biotechnology or medical sciences. Okay. So no matter what's your background, because I've been probably mentoring lots of accelerators, and the government is sponsored accelerators in biotechnology, in different kind of verticals, and everywhere, even in mechanical engineering, the physical aspects of it. I found that software engineering is the key role over there. Okay. A question is, can I get access of courses without the premium? You have access. In that case, if you do not want to go for our CloudxLab premium subscription, you can just go to individual course and buy that individual course. Okay. Those are, yeah. But I'll strongly recommend that in the same amount, you can get a premium subscription. All right, let's start. Okay. So who is a software engineer? Software engineer is responsible for building software. The software could be back-end, front-end, intelligence piece, such as a report, take design, and sometimes a lot of time of a software engineering is to be able to take design versus like whether to build or buy, okay? And be able to take design decisions. A software engineer also must be able to communicate well. So my other suggestion to so all the engineers, all the people who are planning to be a software engineer or any career for that matter, be very good at reading, writing, and speaking. Okay, specifically a common language such as English, because in companies you have people from all over India and all over different languages. Therefore, the only medium that you can settle for is English. Okay. So almost every multinational company or company which is neutral about like across the states, they all have like if specifically software engineering company does not have a bias locally. Maybe a state level jobs, you would need local language. Primarily, you need to be good at, but most of the other jobs, you need to be fluent with English. Okay, so we have seen in past, almost in every job that I have done, and all the people I've hired in past, that those people who communicate well and have a good user empathy, they do better than those who don't. Okay, better than those who don't communicate. All right. Now, a software engineer, the expectation from software engineer is that they should know one is programming language, any programming language, but they should be good with algorithms and data structures. Then they need to know at least how to build a website, because almost every software needs an interface and needs to be accessible from the remote by various people. So no matter what you do, you need to know at least how to build a web application or website. Okay. Any one framework you should be comfortable with. Okay. Why I ask is because the HTTP protocol is very common. And to get an understanding of how a website functions, you need to at least build something, build at least one website. The next thing is the like system design. System design is framework agnostic, but just like here, a common misconception was here, a very big misconception was, I should become very good at C++. No, you should not. Or I should become very good at Java. And when you are asked about some other programming language, then I don't know that language, right? So there was a common mental block, common mistake or misconception that being very good with programming language means knowing all the library functions and everything. It's like being good at language means memorizing all the words in the dictionary. But like knowing English means, or knowing any language for that matter, is being able to express a thought. You got a thought and being able to structure that sentence and say it, right? Similarly, this part was so, wrong. I remember when one of the interviews, somebody in my beginning of the career, I just went for the interview. It must have been 2003 or so. So some startup was hiring, and he asked me, tell me all the functions in Java servlet library, the servlet class. And I said, why are you asking this? And if this is your level of asking questions, probably I'm not suitable for this company, because this is not problem solving. This is not the way you should hire or interview engineers, asking all the functionality, or like checking if they have memorized all the functions in the library. No, you don't need to do that. What is needed is giving a problem statement, like simple problem, like give me all the prime numbers. Okay? Things like that. Are you able to think and code it by yourself? Right? Given a list of numbers, can you order them without using library? Can you order them really fast? Okay? So order as in put them in sequence. Now, that's a hard problem, and that's what you should know, rather than being very good at very good at memorizing every framework and every library and all, right? So this was the first mistake here. Okay. And when I look at these openings by companies that I'm looking for people who are started Java, they're making a mistake. It's a wrong way of hiring, right? It's a wrong way of hiring, because somebody who is very good at Java does not guarantee that they're good at coding. Okay, coding is not Java, coding is not only Python, and coding is not C++. Coding is more about structuring thoughts into code. Okay, therefore, this is a big shift in the industry. People do not care about which programming language you come from. And those who care, they don't know how to hire people. Okay, now, those who care about this programming language, that programming language, like just very, very unprofessional, They do not know how to hire people. Okay. I have coded in probably 14 languages so far. Okay. Sifting between languages did not take me much time. It took me probably 2 days to get fluent with Python and probably a couple of days to get fluent with Go and so on. But my first programming language took a long time. Okay. Next is the web development. Again, understanding web development is not about memorizing all the functionalities of PHP, this, that. No, it's more about understanding how the web functions. Okay. Any framework should be okay. And I've seen in past that the people who are okay with, say, Angular, they can also move to React very quickly. Somebody who is comfortable with Django, they can also quickly move to Node.js and all. So it's more about understanding a framework. Next comes the system design. Now, so what is system design? System design is how do you build large-scale systems? Okay, think about how would somebody build Twitter, how would somebody build Facebook, and so on. System design is a composite of your understanding of the web, your understanding of databases, your understanding of this computer in general, and your understanding of distributed systems, okay, along with your understanding in programming language, okay? The fourth thing that is there is communication. It's no-brainer. I think everybody agrees with it. Do people agree that software engineers need to be good at communication? You can leave your message at the chat. Yeah, everyone? Okay. If you're planning to become somebody has asked a question that I want to become an AI specialist, okay, you can just finish this one, data science specialization. Okay, it'll help you. All right. Now, the next thing I want to focus is, I mean, this is an honest and a generalized way of interviewing. Okay. And there would be variations. There will be companies who hire on X versus Y and so on, right? But this is a general format of hiring, okay? First one is the screening, okay? This is a screening. Now, there are many variants, okay? There are many variants of screening. Some people take aptitude test. Some people take coding tests. Some people ask you to develop a small feature. Like one of the things that when we are hiring people into full stack engineering, one of the tests that we give is build a simple website and build your own custom login system, where it'll ask the login and password and say, congratulations, and it allows you to sign up. It's a small thing, okay? So it's very common these days. And you should just, even if you're very busy with the job, you should take out the weekend and, apply for the screening and finish that. Okay? Now, the next part I want to talk about is, let me just check if everything's okay. Yeah, everything's okay. Okay. Now, the next thing that I want to talk about is the once you clear the screening round, the next part that comes is the tag round. Okay. Usually, most of the companies have 4 rounds of interviews. Sometimes it goes to 6. Okay, but these are the 4 different kind of rounds I'm going to talk about. So there are 4 different kind of rounds after the screening, and These 4 rounds can become 6 rounds or 7 rounds in some cases. Okay. The first kind of round is a tech round. It's involving mostly coding questions. Sometimes a long run project assignment or hackathon is also there in the first round. The second round involves medium or hard coding questions. The third round is usually a system design, such as, which involves a system design questions. And I'll come back to this one. The fourth round is the behavioral round. Now, behavioral rounds are something which essentially checks your cultural fit, checks your understanding of a team, understanding of how good a team player you are, and so on. But if you notice carefully, all of these interview rounds test your communication skill. Like, for example, if you take a look at the coding round, they'll ask you a simple question, and then they'll ask you a simple question. They'll ask you a simple coding question. And once you have answered that coding question, right, and they would not expect you to just code in that interview. What they would expect you, the interviewer would expect you, is that you walk them through your solution. You should be able to explain what code you're talking about. Okay. You should be able to explain how did you think about the problem? How did you break it down into simple steps and so on? And that's why you should, you should work on your communication skill. You should explain a tech problem to a friend and so on, and try explaining the code. So that's why the first important step is to be able to explain your code, right? So whether the tech round, screening round, behavioral round, system design round, one thing is very common, right? One thing is common, that they are your communication skill is being tested. All right. So make sure that you work on your communication skill, and I mean, that's a very critical part. Okay. A question is how to get into private sector. We are talking about exactly same thing here. About this is essentially a process of getting into a private job. Okay, private software engineering job. Okay, there is no straight way. The correct way is make yourself good with the coding and everything, and then you start applying. Okay. All right. I will talk briefly about some part, and then I'll get into the system design. Now, one of the very hard interviews and interview formats are of system design. Okay. If you're already a good software engineer, you need to work upon your system design skills. When somebody gets hired in SDE2 roles, right? SDE2 means like the senior engineer roles. You need to be really good with system design. Okay. And you need to sit down and work on your skill. Okay. Because it tests your lots of skills that we have learned. You will learn at the CloudxLab platform. Okay. Your understanding of systems. Okay. There are all kinds of things, right? System design is a composite of a programming language understanding, your like basics of it, and essentially your data structures, your communication, your understanding of the computer systems. Okay. So it tests your overall understanding of how would you build a web service? What is a web service? Like how would you build something like Google, right? These days, instead of calling it like a server, which keeps on only talk in terms of HTML, people build these independent small servers small servers for every special feature, every specific feature, there is a small server. And your one website talks to like 10 of, or maybe hundreds of these small services and gets the data and displays it. Okay. So essentially web service is like web server or website is made up of lots of small servers hosting lots of different kind of services and give you the details. Okay. So that's a web service. It's essentially a granular part of your website. Okay. And I mean, those who are just a beginner, that would be my definition. And it would also talk, try to calibrate your understanding of how would you build a client, how client as in like the desktop application or non-desktop application, maybe how would you build a performance system? Okay. And then software design skills. What is the meaning of software design, right? There could be one program which is very slow and the other person could make it very fast, right? That requires making the software fast, requires understanding of the problem, understanding of the computer, understanding of how the memory and the CPU behave, right? All of those things that you study as part of data structures and algorithms. Then the next thing that it checks is scalable design, distributed computing. And for this, I would strongly recommend this part of the course, the big data part of the course, because here scalable design and distributed computing means how do you divide workload into multiple computers? How do you get things done using multiple computers, right? Like if you think about it, if you're writing a for loop, which is iterating over an array, that for loop cannot be splitted naturally such that some of the, like half of the for loop runs on one computer, remaining half runs on another. You can't. Therefore, an understanding of system design and distributed computing becomes core to the entire idea. Okay. All right. Thank you so much. I'm really very happy that you are liking it. Do write a review, good review about CloudxLab, and also tell your friends. Okay. Thank you for the wonderful compliment. Okay. Now, in case of system design introduction, right, the way it happens is that the first definition is that basically, how would you build a system? How would you build a website? How would you build a small part of the system or a big part of the system? And the system should be such that it should basically satisfy specified requirements of the users, right? Not only the interface, not only a fully functional piece, it should be able to also run in the specified time, okay? Using limited resources, right? There could be a very, very good and useful thing which basically can run great, but if you can't afford it, it doesn't make sense. For example, long back, Netflix ran this contest, $1 million contest on movie recommendation, right? So they basically gave the data, asked people to come up with a model that gives the best recommendation, and the best team got $1 million. Okay, it was giving great results, but Netflix was not able to productionize that algorithm. They were not able to use it. As of today, Netflix, with the recommendation that you see in Netflix, are not coming from that algorithm for which they paid $1 million. Why? Because they could not productionize it. They could not productionize it. That algorithm, that model, fit very well into the constraints that Netflix in that contest said. But the same model, when they went to deploy, they realized it's not possible because it takes too much of memory, it takes too much of CPU per user, which is not economical. So it should specify. So the requirements of the end customers were not fulfilled by that piece of software, even though it was the costliest piece of software, right? Therefore, system design is a core aspect in which you try to build things which satisfy the requirements of users. Okay. All right. So there are two kind of requirements, right? One is functional requirement, and then there is a scale or capacity. Functional requirement is what all should I display here? What all information do we need here? Where will this information come from? Should I display it like this or like that? So those are functional requirements. What all information you need to display in what order? Okay. The second aspect of the system design is understanding the non-functional requirements. What are non-functional requirements? Such as scale. How many users are going to be there? Okay. If you think about it, Twitter has only a small functionality, not too many, small functionality. Now, Twitter has small functionalities, but the scale is very high. The capacity is very high. The capacity requirement is very high. The capacity in the sense like how many servers are needed to run it. That's the capacity planning. Next is, next thing about system design is like when you say requirements is, what endpoints are we going to give? What is endpoint? Like when you go to, let's say, Google here or here, you see here? So this is like, if this is a service, this is a service. So one of the endpoint is like slash. We are asking slash, can you give me this data? Give me this URL, right? Those are endpoints, okay? So what are the endpoints that are needed in this server, okay? Then what we do is, as part of system design, once we have cleared functional requirements, scale and capacity from the interviewer, and also have cleared the endpoints, like these are the things that you're looking for, right? So here, once you have clarified that, what you do? You start with small scale design. You'll say, okay, let's just assume for now that we'll have 1,000 users or maybe 50,000 users, and we will start on a smaller scale. Why small scale design? Not why not just directly jump to the final? Because small scale design gives you clarity on functional requirements. It also makes you think about functional requirements so that you can then increase the scale. Then comes scaling out. The moment you do the scaling out, chances are that you will be stretching your small scale design, or maybe you will be deleting some part of classes or some part of database table and coming up with a new design. So all the work that you're doing here, it kind of goes useless the moment you start scaling out. But still, this is the correct way of approaching a problem. If you directly scale out, you won't do a good justice. You would not realize which side should I scale out, which scale out as in increase this, like scale it to, if let's say one server is there, we designed it for 10 users. If we have like 10 million users, how are we going to handle it? So you go stepwise. In the interview, talk about functional requirement, non-functional requirements, then what endpoints are going to be there. Then you talk about small scale design. Then you talk about how would you scale, okay? And towards the end, make sure that you save around 5 minutes of time to discuss what are the limitations of your system, okay? And what are the trade-offs that you have taken in order to scaling out? You might say, okay, I'm going to have like 5 servers, and out of these 5 servers, one is going to be master, another is going to be this. We'll say, okay, the limitation of this design is that even though it's going to serve well, but the data could be a bit stale. Eventually, things will be okay, but while the main server is copying data to the other one, it might basically delay, or it might look like laggy. Okay. And here you should also mention what are the scope of further improvement. So you keep, say, couple of minutes for functional requirements, couple of minutes for scale, and couple of minutes for endpoint design. Then you have, let's say, 10 minutes for small scale design. Okay. Then 10 to 15 minutes to this, and last 5 minutes here. So 5 minutes, 5 minutes, 10 minutes, and you are left with usually total 45 minutes. So you're left with 35 minutes. 5 minutes is for introduction, so we're left with 30 minutes. So 15 minutes, 15 minutes is good idea, or 10 minutes and 20 minutes. Okay, so that kind of a breakdown you should do. All right. So instead of talking in air, I want to walk you through, let's say, a design interview. Let's say in an interview, somebody asks, like, how do you design Twitter? So how, let's say this is the format of starting format of an interview on system design. System design interviews are crucial to your career, crucial to almost every job today. Okay. So those who have done basic programming, they should, and basics of data structures, they should definitely start working on system design preparation. So the interviewer asked, like, okay, Lisa, let's start. Can you design a system like Twitter? Now, this is the question that interview poses to you. Okay. Instead of just jumping into the design, oh, I know this, and you say, okay, I'll answer quickly, right? Don't do that. Don't do that. It's not the traditional exam. I've seen many people, oh, Twitter will design like this. I've studied in the, I memorized the entire design. Even then, even if you have studied, even after attending this interview, this webinar, when you go to a real interview, and you just happen to get the same question, can you design a system like Twitter? Don't just give my design whatever I'm giving. Instead, go through these steps. Very, very, very critical. And this is the biggest mistake almost every senior engineer makes. Okay, they just jump to conclusions, jump to the answer. No, I'm not looking for answer. Your interviewer is not going to design Twitter. They're looking for how you think. They're looking for how you go stepwise. They're looking for your approach, not your answers. I mean, it's not like your answer is going to solve their problem. No, nobody cares to them about this interview. Okay. So my strong suggestion is, don't just jump to the answer. Follow this process of interviewing. Okay. This will definitely change you as a person. Right? All right. So here, in return, your answer should be that, hey, can you tell me what kind of features you're looking for? In return, the interviewer might say that, okay, you can take assumptions and you can say that, hey, I have not used Twitter, so I don't know what are the functionality. Okay. At that point of time, the interview might himself or herself give you the details about functionality. Okay. So if you know what is Twitter, just say that, hey, I know that these are the functionality, what are you looking for? And then, right. So in this case, the interviewer says, okay, we are just looking for a minimal functionality where users should be able to post tweets, view tweets, follow, unfollow Twitters, and so on. Now, here is an important question, and you must ask questions. When you think about Twitter, what are the functionalities, what are the various features? The questions, you must ask questions such as, how is this feed sorted? On what basis are we going to sort the feed, right? Should it be based on relevance, based on how important is the person, and so on? So at this point of time, if the interviewer says that, okay, the feed is going to be sorted on relevance, okay? If the interviewer says that feed is going to be sorted based on relevance and all of that, that means the interviewer is looking for a machine learning system design interview, not a normal system design interview. Okay. So to keep things simple, let's assume that the interviewer is saying that, okay, let's just keep things simple and assume that the feed is sorted by reverse chronological order. Okay. Reverse chronological order is the feed, the items are, the most recent ones are at the top. Okay. Next question is, how many followers can a user have? Okay. Now the interview tells you, you can assume that each person can have up to 5,000 followers. Then what's the traffic volume? What's the volume of the traffic that we're expecting? So you can say that here the interviewer says that, okay, they're going to be 300 million monthly active users, 50% of the users use Twitter daily, and users post 2 tweets on an average. Okay. At this point of time, you should do the back of the envelope calculation and come up with actual numbers. Okay. And you should come up with the numbers that, okay, these many requests per second are going to be there, and over 5 years of time, this much data is going to be there. Here, the next important question is, can tweet contain images, video, or just text? It's a very important question, and you should clarify whatever comes to your mind. You must clarify. Okay. You can say that, okay, 10% of the tweets contain some media and data is to be stored for 5 years. Okay. At this point of time, you got a fair bit of idea about expectation. And when you get the fair bit of idea about expectation, you should write it down very clearly in your notes that I'm going to design a system which basically going to have 300 million monthly active users. Out of these 300 million monthly active users, around 150 million users come daily. Users post 2 tweets daily on an average. That means 300 million tweets on an average in a day. Okay. You should also calculate how many concurrent users are going to be there. How do you do that? 150 million, which is 50% users, divided by, right, 150 million users divided 150 million divided by 12 hours, 24 hours. So that will become your per second limit. Now this is a humongous limit, right? This is a humongous limit. You can quickly see, right? If you have, let's say 150 million users divided by into 3600, right? So we can quickly say that, okay, breaking it down, this becomes 10,000, right? I divide by 3, multiply by 3, so it becomes 10,000. So 10,000 has 4 zeros, so this becomes a square. And, right, this is approximately 2, so it becomes 20. And so we can say 2,000 requests of write, like 2,000 requests of write are basically, 2,000 users, concurrent users in a day, 2,000 users per second. Sorry, this is 2,000 users per second. Okay, is the concurrency window we're keeping at 1 second, 2,000 concurrent users. You see the kind of traffic we're going to talk about. Okay. All right. And you also have to do a calculation on how many active users are there. They're posting tweets in a day and how much sizes of each tweet. And you can quickly calculate what kind of data is accumulated for 5 years. Okay. So now you'll have, right. The other thing you need to know before you design anything is this. Okay. You need to know that network is slowest. Okay. You can see this as you go down, it is slow. This is network. Then comes disk. Disk is like hard disk. Then comes SSD. And then comes RAM. And then other, registers and other stuff that processor. So as you go down, you have this. So network is slowest and registers are the fastest, or RAM is fastest, and right, and so on. So you should understand this part. Okay. And you should also understand here that RAM is 20 times slower than registers and L1 cache. Yeah. Okay. 20 times slower than those. Now you can also see that SSD is about, you can see here, SSD is 4 times slower than the RAM. SSD is 4x slower than the RAM. RAM is 20 times slower than the registers. SSD is 4 times slower than the RAM. And then disk is around 20 times. Okay. Yeah, I think. See, this is okay. Yeah. Disk is around 10 times slower than SSD. And the network is around, network is this. Okay. No, this is 20 times. Sorry. This is, you can see, disk, reading something from disk is 80 times slower than the memory. 80 times slower than the memory and 20 times slower than the disk. Okay. 4 times 20. Okay. So these are the numbers that all of you must know by heart. Okay. All right. So here's a brief calculation. Daily active users are going to be 150 million tweets. QPS is approximately 3,500 tweets per day. Tweets, yeah, per second, they're going to be this much. And queries per second. QPS is queries per second. QPS, we can just multiply that with 2, so around 7,000 queries per second. And average tweet size, you can consider that, okay, one tweet is going to take 64 bytes, text is going to be 140 bytes, and media could be 1 megabyte, or maybe 2 megabytes or half megabyte. So we can just take average as 1 megabyte. And then estimated media storage is going to be this. Okay, so 30 terabyte per day of the data. Okay, you see the data? 150 million multiplied by 2 tweets per user, and yeah. So, and this is the size. Okay, so total in 5 years, you need a storage of 55 petabyte. So that means to store this kind of data, you can't really use a single computer. You can't use a supercomputer. You need a distributed computing system. Okay. So according to the functional requirements, we can see there are 3 flows. Okay. Posting the tweet, building the tweet feed for the followers, and then follow, unfollow. Okay. The features. We are talking about functional requirements now. All right. So you need to know what's a get and what's a post. Get method is about retrieving the data from server. Post is about modifying it. Okay. This is a hard question. So, and you might be asked this question. Okay. And lots of senior engineers ask me that why do we need post? Why can't we just do everything in get? Okay. Even like submitting a form can be done using get request on the website. Then why do we need post? Yes, that's a very important question. Like, see, get requests get cached by various servers in the midway. So in case any URL is changing the state of the server, the data is getting updated, make it post. Otherwise, it could create chaos. Amazon, during one of the hard times, it ended up delivering around 100 items to one person. Okay. 100 items to one person. Why? Because add to cart was a get request instead of a post. The cache kept on preparing it again and again, and it kept on trying again, and it kept on placing an order. Okay, so anything, never have anything that changes the state of the server as GET request. Okay. Now, publishing a tweet. To publish the tweet, a HTTP request will be sent to the server containing parameters. Like so. So here, this is what I'm going to design. So we are going to have these endpoints. These are the endpoint design that we're talking about. So we are saying post, tweets, user feed, and this is the content, this is the user ID. And to retrieve tweets for the feed, a GET request will be sent to the server containing parameters and so on. Okay. Now, before you begin with a large scale system design, you should design the system for a small scale. Okay. Now, a common question that people ask and people do not know is what is RDBMS? You must know a small scale design. And for that, I think starting with the RDBMS is a better idea. Though, know that the moment you scale your design, chances are that you will not use RDBMS. You might be using MongoDB or CouchDB or this and that. There are hundreds of NoSQL databases. So, but it is very important to know the RDBMS-based design because that helps you clear the idea of entities. Okay. So, like you have tables and tables have relationship and so on. So those things you need to be clear about. Now, in our case, what we're going to do is we're going to design a table called tweets. It has tweet ID, posted by, posted at, and text and image. Now, image URL, why it's an image URL, not the image data. The reason is usually what people do is they upload the data of the image onto S3 bucket. We call them CDN service. Okay. CDN service. Okay. So here, CDN gives you the URL. Like if you take a look at any of the images on the internet, you'll find that that image is hosted on some CDN. There are many kind of CDNs, like Google has their CDN, Amazon provides you S3, and the Cloudflare provides you CDN. Okay. And then we're going to have a table called followers. This user ID has this follower. So if there are multiple followers for the same user ID, we'll have multiple rows. Okay. And the user ID will repeat. Now, user will be another table. This is another entity whereby it has user ID, name, and other details. Okay, there might be hundreds of columns. All right. All right. Now, the next, the next thing is, right, there's going to be a relationship, right? Say, for example, posted by will contain an ID, and that ID, the meaning of that ID is in this table. Similarly, follower ID will be here as a number, and that meaning of that ID is going to be here. Similarly, user ID is also a user, right? Now, at this point of time, interviewer might ask you that, can you just write a query to prepare the feed once you have designed? So you'll say, okay, select start from tweets, and then you join this table with that table, and you give out. Okay. Now, the next question that the interviewer will ask that, how will somebody follow and unfollow? You'll say, okay, if somebody follows, we'll insert an entry into this table called followers. And in case somebody unfollows, we'll delete that entry from followers. Okay. So these are the three queries for three functionalities. And the way the flow goes is that user will come to our server, and here we will upload the data to S3 storage, and S3 storage will give us our CDN storage, and CDN storage will give you the URL, and then the URL will go into the database. Okay. Now, this is good. This is good, and you should always focus on doing this. Because everybody knows in industry that designing database models is something that is mandatory. Okay. So this part that interviewer has been waiting that you code it up. Okay. Now, you will immediately say that, okay, this design is not going to be handled. This design is not going to handle 7,000 QPS. It can store it cannot store 30 terabytes per day. Okay. And here there's a can't, not can, it's can't. Okay. And it can handle that kind of load, right? So what you do, you talk about, you need to know about load balancers and other things. So load balancers, what do load balancers do? Load balancers are basically that divide the traffic onto multiple servers. Okay, they balance the load. All right. Like for example, when a request comes to a server, it divides the load onto multiple machines. Then what is sharding? There is another terminology that we will use is called sharding. Sharding is a way of dividing a big data set onto multiple machines. Like, for example, if users data set becomes very big, we will split it into, say, multiple servers, and based on a certain criteria, we will divide and distribute the traffic. This helps us in horizontal scaling, meaning the more number of users we get, we keep on adding more servers, and the sharding will help us. Okay. This is the general style of things, right? So database is divided into parts. This contains some data, this contains some data, this contains some data. Shards are defined based on certain key, such as user ID, or it could be based on some other characteristic. Okay. User comes to the load balancer, right? Load balancer is a server, or sometimes you call it gateway. User comes to the load balancer. Load balancer distributes the load on multiple servers. This is server 1, server 2, server 3. Every server talks to the individual shards, and then it gives you the results, right? Now, if let's say the request is coming, let's say for follow, unfollow, and all, it's going to be faster. But again, if you look at here, that when somebody says, let's say user comes and says, give me the feed, right? Give me my feed. Now this feed, for this user, we mapped it to say this server, right? And then the server will basically talk to find out all its followers and everything, and then prepare the feed and give it back. So this way it will prepare the feed. The workload is divided into multiple databases. Similarly, users have been divided onto multiple servers. Imagine you have 10,000, let's say you have 1,000 servers, and you have, say, 10,000 users coming parallelly. So one user will be catered by one server at a time. Okay. Now, question is that feed will still take time. Why? Because that running that query is going to take time. And it is not a great idea to run the query every time. So question is, what can we do in order to make that running of that select query faster? Okay. All I care about is when a user comes to Twitter, they should be able to see the tweets from all the people they are following, right? Let's say I'm following 100 people. I should be able to see that. So question is, can we just keep it ready? Like for the people who are very active on Twitter, we will basically just keep their feed ready. Now, how to keep the feed ready? So what we can do is we can figure out like the very frequent users who just came in last one day. We'll just keep those users, and out of those users, what we will do is, right, that we will basically keep their feed ready. Okay, we will essentially just do that. Now, question is, let's say I'm following 100 people, my feed is already prepared. If those 100 people tweet, right, my feed has to be updated, correct? So we need to update this cached feed also. Okay, so cache is a high speed data storage, specifically mostly in the RAM, and Redis is a software that provides a very nice cache. Memcached is another software that provides a very nice caching functionality. Okay, so what you do is you keep the caching servers like server 1, server 2, server 3. And when the request comes, let's say this user is asking for the feed, the web server comes here. It basically checks, like this web server checks with the caching server that, do you have the feed for this user? He says, no, I don't have. Then he runs the query and gets the data from actual database and then puts that in cache as well as tell the user. Now, the second user comes and says, hey, and here web server checks, okay, this person, we already have the cache. We already have cached their feed. So we'll just return that feed. So this will become like 40 times, 80 times faster than the other one. Okay. And then let's say the other one tweets, somebody is tweeting. So what you do is you check if the followers are in the cache or not, and then you update the cache. Okay. That's what you do. So this is what it is. So for all active users, keep the feed ready in the cache. Those people who are very active on say Twitter, we keep their feed ready and we update the feed whenever someone they follow makes a post of a tweet. So when a user posts a tweet, what you do is update database table called tweets, find all the followers of this user. If the feed of the follower exists in the cache, then append the tweet to it. If the size of the feed is bigger than 100, remove the first tweet, right? Because you will maintain those, right? Essentially, what we want to do is we just want to keep the feed containing only most recent 100 tweets, because otherwise what will happen is, let's say I am an active user, my feed object will keep on becoming bigger and bigger and bigger if somebody in my friend list is posting, right? That means this feed object will keep on occupying more and more memory, and memory is precious. Therefore, what you do is you do not keep more than 100. So what we do is we basically remove the first tweet. Okay. Now, so if, let's say when a user accesses the feed, if the feed is not available in the cache, prepare the feed by querying the various shards, add the feed in the cache, and the cache must expire after 24 hours, this person's cache. Okay. And basically in case a user is active, we mark it like, okay, this user is active, don't expire his cache or his or her cache. Okay. When a user follows or unfollows, rebuild the feed. Let's say I unfollowed somebody, right? So my feed has to be, rebuilt. Similarly, if I am following somebody, so my feed has to be updated to include the tweets by the other person. Okay. Now the question, here are a couple of questions which are more related to data structure, and there would be variations to it. How do you maintain at most 100 tweets in the cache? Like in the cache, it's like key value. And whenever there's a change, we have to delete the first tweet and so on. Correct? The oldest tweet. So how do you maintain the most tweets in the cache? Okay. So this is essentially called, moving window kind of thing. And what people usually do is they maintain a circular queue. Okay, the circular queue contains 100 elements, and then as you reach to the first, as you cross the 100th limit, you basically start overwriting the first element. Okay, so imagine that you have a circle containing 100 slots. Okay, and basically have this in this cube. Okay, so initially it is pointing to this one. Okay, and somebody comes and okay, my fee, like my friend has tweeted, so his tweet goes here, and this pointer moves ahead. Then again, somebody tweets, somebody tweets, somebody tweets. This pointer keeps moving, and the moment it reaches here, here, and again, my friend has tweeted, so this get deleted and the new one get added. Okay, so this way, all the time we will have 100 tweets. Okay, we will have 100 tweets, and that's how you essentially maintain 100 tweets in the cache. Because if let's say there is you maintain these are my 100 tweets in this array, let's say first tweet came, second tweet came, third tweet came, fourth tweet came, fifth tweet came, like the 100 tweet came, now the first one has to be deleted. If you delete the first one, what will happen? All of these will move, right? So therefore, if you just keep this in array, it becomes very inefficient. Okay, very inefficient. Therefore, you need to maintain a, right? Yes, this is more like a LRU, but not really LRU. LRU is least recently used, but this is more like whatever is most recent item. Okay, so LRU is a little bit harder design. This is way more simpler design. Okay. Good question. Very good question. Whether it's like an LRU. Now, next is how would you suggest, how would you design efficiently expire cache, right? I said that, okay, we are keeping the feed of everybody prepared in the memory, right? And this has to expire. How do you expire it? How would you design a scheduler? So I would suggest that take a look at min heap. Usually most of the schedulers are a min heap. Okay. So take a look at that. That will be your answer. Now, next question, be ready for these follow-up questions. Next question is, how do you store such kind of humongous data? In this case, you should say that, okay, we will use things like MongoDB or probably HDFS or HBase, a distributed file system. And if the interviewer says that, can you explain to me how do these systems work? Then you can explain their design. They're saying that, okay, HBase stores the data into multiple computers and hundreds of computers can store the data. And similarly, MongoDB can also be used in the same way. Right? All right. So I would, that is pretty much from my side. I would say that go for CloudxLab premium subscription. You will learn a lot of things, starting with programming and all the engineering. And my humble request to everybody is, no matter whose course you take, ask for hands-on, or if they are not providing hands-on, whether you are in a college, a school, or you are basically being taught in your company and upskilled, sign up for the lab. Okay, if your company wants to take up a lab, like most of the companies take up lab with CloudxLab, feel free to reach out to us. We would love to give you the lab, because the lab we have on the cloud, as well as the premium courses along with the staged lab, has proven very successful in industry. Okay, you can just take a look at LinkedIn and find out how many people have taken the CloudxLab certification, and check where they are. They're doing wonderful in career. Okay, most of the tech leaders that I met, they have taken the lab in past. Okay, so my request would be that go for premium subscription. It comes with courses, it comes with the lab, and wherever you are, if you've taken some other course, just take the lab, and it'll give you hands-on experience of all the tools that are needed. So thank you so much for a wonderful set of questions. If you have any more questions, come over to discuss.CloudxLab. Also, yeah. A question from Nikki is, does Free Code Camp offer system design course? Yeah. So the premium subscription is basically containing the course on data engineering. And one thing I recommend every engineer is to go through the design that I discussed in that course. There I have discussed, in this course, I have discussed the design of Zookeeper. Okay. Design of Zookeeper. Right. And then I discussed the design of HDFS. I discussed the design of Yarn. I've discussed the design of MapReduce, discussed design of Hive, discussed the design of, let's say, NoSQL's HBase. I've also discussed the designs of Apache Spark and so on. So what I'm saying is, once you have gone through this, you will know all the kind of the standard designs. And when a problem comes, that how do you build this? You can actually, the only way you can understand design is by looking at the standard designs of these large scale systems. And that's what this course does. Okay. This course ramps you up in that. One more thing I forgot is Apache Kafka is there. You must take a look at the Kafka. Okay. So here I have, yeah. So, okay. In the data engineering is there. All right. So that's pretty much. And make yourself comfortable with these ideas. A question from Atul is, any book recommendation on system design? There are quite a few books and on the internet, on Amazon, you can take a look. All right. A question is, this course is useful for? This course is essentially like the data engineering part of it. So data science course has two parts to it. One is data engineering and other is machine learning, right? So this course, and there are so many courses as part of premium subscription, right? You should take a look. So data science is data engineering, machine learning, deep learning. This is data engineering. This is data engineering. And this includes the deep learning as well, machine learning and deep learning and so on. So most of these courses are very overlapping. I would suggest just pick a track and then finish that track. Okay. So these courses will help you become senior engineer. The courses will help you in becoming machine learning engineer, data scientist, data analyst, software engineers, and so on. Okay. So start your journey today. Okay. It just like probably this would be the least, the lowest cost course with the embedded or the holistic experience on the planet. Okay. And feel free to reach out to us at any point of time. Okay. And right now there's a lot of offer going on, so you can just avail that offer. And yeah. Wonderful. Thank you so much for the questions. There's one more question. Do they ask system design question for 20 years experience in service company? If you have 20 years of experience, it is guaranteed that you'll be asked machine learning, you'll be asked system design. Yes. And yes, even in service company, IT service company, people have started asking all really, really hard questions. I was talking to a couple of companies and I realized that they have all taken inspiration from Google and Facebook and they are going that route. All right. So it's guaranteed that if you have experience or even 2 years of experience, people are going to ask you system design questions. Okay. And if you are applying for senior software engineer, it is guaranteed that they will ask. Okay. All right. So thank you so much. I hope this session was useful to you. And I would strongly recommend everybody to do more and more hands-on. Okay. Do not wait for the time when it's too late. Start your learning today. All right. And no matter where you are doing course, take the lab. Okay, be more and more hands-on. All right. Thank you so much and have a good day. Yes, there's a placement assistance. We conduct the placement eligibility test. If you perform great, we would be, we would be, we would be, you know, if you perform great in the placement eligibility test, we'll be connecting to your to connecting you to our hiring partners. Okay. Thank you so much. I hope that you were benefited and have a good day.